So tell me, guys, once you're done with the graph, just let me know. You all can switch on your video. Let me see if I'm doing or not. Am I audible, guys?
Sir, I was in the last class, so I don't know.
Yeah, not an issue. You're saying Vedang, no?
Yes, sir. I just got the recording playlist yesterday, so I'll be seeing them today.
Okay, not an issue. Okay, guys. So, okay, you switch on your video just for some time. Solve this question. Everyone, please switch on. Okay, so now solve this. Okay, what you are trying to do, we have to convert this entire diagram into some graph, some triangle, and the length of the GT part, this length will be a variable, so you can choose whatever length you want. This is just a practice to realize that what we are trying to achieve. For example, if I draw something like this, I'm calling this as V naught. From the tip of the first vector, draw the another vector called GT vector. Now, if you draw GT vector, it will grow like this. It can be this much or bigger, maybe here, or it may go down also. So it will keep on increasing in length. So my question is, how you are going to draw it at any instant before the maximum height? So let's say you are here and you are making some angle alpha. And the velocity is something v. Can you plot this situation in a triangle, or at least try doing this? So how to draw it? That's the question. How we should draw it to take care of this two instant t is 0 and t equals to t. I don't know what is time, but I know that at this instant my velocity vector is making alpha angle with horizontal and it is elevated up only. So what kind of diagram we should draw to tackle this situation? I mean, it can depict the same event in a graphical way. So today will be practice, because this is challenging part, and I know this requires some practice before we can create the intuition about it. Rugved, are you there?
Yeah.
Yeah, you can switch on your video. So just draw this triangle, which can take care of the theta and alpha. Once you master this, things will be quite easy for you going forward. All right, so you can try this. And once you're done, just let me know. I'll draw it and you can match. Once you're done, have you done with the triangle? Just let me know once you're done. What I'll do is I'll draw it and you can just see yourself that is it matching or not. So you can see V is still up. It is above the horizontal. So if I draw the horizontal or horizon like this, if I call this angle as theta, even the V vector should be above this line or below the line. The V
Below
vector
the
should
line.
be above this line or below the line.
The below.
Below the horizon. Can you see V vector is
above.
below or above?
Above.
Yeah. But the angle is less than before, right? Do you realize angle is less than before? That is the relation part. Angle is less than before, which means the GT should not go much below. It should be stopping somewhere here. And now comes the V vector, which is the resultant of the first two vector. And you can see this V making alpha angle. How many of you are able to realize this event? That how the simple concept of projectile motion can be depicted using triangle law. If this is making some sense to you, do let me know. Else I will again explain because I know it's difficult.
Sir, understood.
Very good.
Sir, one question.
Yes.
They will have, I mean, obviously they'll start bending at a point. So what point would it be, in when it won't move in a straight line?
Which one? The
Any
actual.
projectile. Yeah.
Ah. So what you are saying, asking when it is going to be horizontal like this?
Yeah. When is it going to go horizontal? When do you
Yeah,
know?
it's exactly here. See,
Oh, okay.
when GT will be touching the horizon, the resultant will be horizontal, isn't it?
Yeah.
And when the GT exceed this value, it will go below, downward. It is like coming down. So if you choose any point here, you can see V vector is going to be like this, isn't it?
Yeah, sir.
And it means it is below the horizon, correct?
Yeah. Okay.
It is below the horizon. It means the GT has exceeded the horizon value and it is bigger than this length. So it will come down somewhere here. And that's why if you join the beginning of the first vector to the end of the second, you will get a vector like this, which will exactly depict what you're trying to ask. Okay. So it's very interesting. I mean, if you think this way, it's pretty easy. Now, what is our question? What we are trying to achieve? We are trying to understand that after what time the velocity vector will make alpha angle. That is what I'm trying to achieve. So can we say the GT must be above the horizon? The length of GT must not be touching the horizon. Can we say yes or no? Tell me, guys. Can we say GT must be above the horizon? This length must be less than this height. Can we say yes or no?
Yes, sir.
So now if you look at this entire thing, it is a simple triangle. And of course, some advanced mathematics we can use to solve it in an easier fashion. But as of now, this length is GT. What is this angle, guys? Tell me. What is this angle?
Theta minus alpha.
Excellent. And what is this length? V not correct. And this length is V. If you need, you can find it. But more than that, can you tell me what is this angle? What is this angle? You can find the angle from the actual triangle, right?
90 minus theta.
Excellent. Because the entire angle is theta, this is 90. Can we say this is 90 minus theta? Yes, we can say. And this is alpha, by the way. So can you tell me what is this angle? Anybody? How much is this angle? Let's call beta, and we know we can use the property of triangle that sum of the angle is 180. So theta minus alpha plus 90
Right.
minus theta plus beta is 180.
90.
Right, guys? So beta turns out to be how much? 90 plus alpha. Can we say yes or no? Can we say? So beta is 90 plus alpha. Is this part clear? Yes or no?
Yes, sir.
Yes, sir.
Okay, great. Now I'll give you something mathematically advanced knowledge. I mean, of course, you can use it, but anyway, let's say what you want. Do you want GT value? You want GT? Okay. So let's say I am looking for time. How to find time? So there are many ways in which I can solve. So we have something called sine law, which I'll prove also in the due course of vector only. So sine law comes from mathematics, which we can prove very easily using the vector notation, which is part of our syllabus. We'll learn at the end of this chapter. But because I need to use it right away, I'll tell you how to use it. So the side opposite to the vertex A is called A. The side opposite to the vertex B is called small b and small c. This is called angle A, this is called angle B, this is called angle C. Now what sine law says? The side upon sine of angle, the ratio remains constant. So this is the sine law, which I will prove later on, don't worry. And this is the very powerful method to solve triangle problems without thinking about sine, tan, cos, without thinking about Pythagoras. So now using this method, what we can write? GT upon the angle in front of it. What is the angle? What is the angle in front of the GT side? Who will tell me?
Theta minus alpha.
Very good. So we can write sine of theta minus alpha. And this must be equal to, let's say, V naught upon which angle? So what is the angle in front of side V naught? Can you tell me by looking at the diagram?
Sir, beta.
Yeah. So what is beta, by the way? Beta here is
90
plus
plus alpha.
90 plus alpha. Very good. So can we write here sine 90 plus alpha? And you have solved one of the challenging problem of projectile motion in one line. So when you will study the chapter kinematics, again we are going to learn these questions. But of course, there I will explain through the component, a lengthy method, a very lengthy method. Right now you're seeing the simple application of vector to deal with even the most challenging problem. And here, why I choose these two? I could have written V also. What is V upon? What is the angle in front of V side?
90 minus theta.
So sine 90 minus theta. You can call these as equation 1, 2, and 3. So you can say this equation as 1, 2, and 3. So the first two equation, 1 and 2, is sufficient to get the time, isn't it? If I solve the first two equation 1 and 2, can we get the t value? Because everything else is given to us. Alpha is given, theta is given, g is known, v naught is known. So equation 1 and 2 will give you the answer. Can you tell me what is the answer using equation 1 and 2? How to write t equals to? So using equation 1 and 2, I'm going to next page. If you want to write something, please finish the writing. And everyone should be writing. That's very important. In physics or mathematics or any subject, you cannot learn without writing. So make sure that you all are writing. Everyone is writing everything. You can write in rough, that's okay. Because anyway, I'm going to share the notes, so that's not an issue. But make sure you all are writing. So how much the t is coming?
The t is equal to v naught sine theta minus alpha upon g into sine 90 plus alpha.
Which is okay. So you will also come to know that sine of 90 plus minus theta is always cos theta. So this is how you can simplify. So very soon I'm going to start the mathematical tools after the vector chapter, in which we'll learn about the mathematics, the basic, the mathematics that we need for physics. We'll try to cover many aspects of mathematics as much as possible. So anyway, now this will simplify further my relation. I'm going to use the next page. So using 1 and 2, gt upon sine theta minus alpha equals to v naught upon cos alpha. I'm simplifying the sine 90 plus alpha, and this gives me the direct answer. T is how much? So here is the answer. Okay, that's very vector method of solving the same question of projectile. In the same question of projectile motion, every event will happen twice, except the event which is happening at maximum height. So if I say that this was v naught and this was theta, and if I say this is v and this is alpha, while coming down, it will again form alpha, but below the horizon because of symmetricity. So you got the answer for this t. Let's call t1. So can you tell me what is t2? Find t2. So try this question again with this new perspective that we have to find the t2 when the velocity vector is making alpha but below the horizon. So gt will stretch below the horizon, right? You have to keep on pulling the gt till you get alpha below. So can you draw and see for yourself how the triangle looks like? And then probably you can match with the answer which I will eventually give. I believe that you can get the answer without my help. That's really good to see. And make sure that you do it. Once you have learned the concept, put your effort. Don't wait for me to answer. You try to give your answer. In the worst case, try to take help from me.
Sir, I have a doubt.
Yes.
Sir, your T1 is time taken from which point to which point?
T1 is from beginning the time you projected till the angle become alpha for the first time. So from here, origin to here, this is the time.
Okay, sir.
And T2 will be from here to entire time here till here. So T2 is from since you threw this object till you're now bending down.
Okay, sir.
Yeah. The moment you draw the triangle, you can use the sine law as I discussed to get the answer. Answer will be pretty much similar with a small change.
So I got the answer as V naught sine theta plus alpha upon G cos alpha.
That's the right answer. Excellent. Very good. So you must have this triangle. Let me just draw the triangle. Since you got the answer, I can draw now. So the GT will grow like this, like this, like this, like this, like this, till the V vector makes alpha below the horizon, right? That's the whole idea. So this is my V vector, which makes an alpha with horizon. This was theta. And this entire length is GT. I hope you are realizing this part. This is GT, right? And this angle is known to us. This is how much? 90 minus theta. And this is how much, by the way?
90 minus alpha.
Excellent. So I think we have a triangle and we know what to be done, right? When we have a triangle, what we can do? We can use the sine law. So apply, let me say applying sine law. I will not do anything. You will tell me, I will write. So who will tell me? Tell me what should I write here?
So GT upon
GT
sine
upon sine
plus
theta plus alpha.
Correct. Equals to V naught upon
Sine 90 minus alpha.
90 plus
cos
sine
alpha.
90 minus alpha,
Minus
right?
alpha.
minus
Which will become cos alpha. Can I directly, if it is okay?
Yes, sir.
And then, although it's not required, but you can use it for finding the velocity. The V will be how much? V upon
Cos theta.
cos theta. In fact, these two you can use to get the velocity itself, right? Which is pretty much logical. So V by cos theta is V naught by cos alpha. So basically, you can get the answer. Anyway, so what we're looking for is time. So I will use the first two equations. And I'm writing directly the GT upon sine theta plus alpha is equals to V naught by cos alpha. And so the time I got T is V naught, sorry, sine theta plus alpha upon G cos alpha. And basically this is T2, right? So the other question that you may expect in the projectile question is, what is the difference of the time? What is the interval? So that could be the third question that you can answer easily. So the interval is simply the difference. So tell me guys how to write delta T. We can write, we can take something common, right? We can take common V naught by G cos alpha, right? So we are left with sine theta plus alpha minus sine theta minus alpha. Now this requires some trigonometric identities, which let me write down. So sine A plus B, you might have studied in maths. Have you studied this problem in maths?
Yes, sir.
Sine A cos B plus cos A sine.
Excellent. Sine A cos B plus cos A sine. And similarly, sine A minus B is equals to what we can write?
Sine A cos B minus cos A sine B.
So a similar thing, if I add these two equations, in fact, I get a very nice relation. Sine A plus B plus sine A minus B is actually equals to 2 sine A cos B. So this will cancel out, right? If I add these two. So this is also a formula that you can remember. So using this relation, and see, trigo is something that I will be using again and again. And I'll keep on writing because that will create the muscle memory for you if you keep on watching or seeing the same thing again. So delta t turns out to be how much? V naught by G cos alpha into 2 sine A into cos B.
So it will be two sine alpha.
2 sine theta, na? A is
2
what?
sine alpha cos theta.
This is A, na?
Because there is a minus sign, a sine theta plus alpha minus.
My bad, my bad. Okay, we are finding the minus, right. My bad. Okay, yeah, we are not adding it. So let me complete this part. So here, sine A plus B, sorry, minus sine A minus B, the difference will be 2 cos A sine B. Correct. Thanks for correcting. So delta t turns out to be how much? 2 cos A, which is cos theta, sine alpha. So we get a really nice answer. We get 2 V naught by G into cos theta tan alpha. That's simple way of writing. So now this is a really big question, a challenging problem actually. But using simple rules of vector addition, we can simplify this. Okay, so the more you understand about the vector, the more you understand about the various manipulation that vector is capable of performing, your entire journey to learn the physics will become pretty easy, pretty easy. Like, trust me, I am putting more stress here right now because you may be thinking that vector should be easy. No, I am trying to make a vector as comprehensive as possible because after that the entire physics is easy. Nothing is left in physics. So put more effort here, you will have a really nice time later on. So similarly, I want you to solve some more problem so that you can realize what is happening. So this is something called horizontal projectile motion. Again, it doesn't matter for you. What really matters is you're throwing something horizontally. So you're throwing something horizontally with velocity v naught from the height h. Okay, so if you throw something like this, what will happen? It will go like this. And it will hit at some angle. It will hit at some angle with some speed. The angle may be theta. I don't know what is this angle. Okay. So the first question is, do we know theta? Do we know theta? Yes or no? Is theta known here or unknown here? Rugved, is theta known or unknown? It's unknown, correct? I think your mic was muted actually. Anyway, I think you said something, right? So tell me, guys, is theta known or unknown? Everyone's mic is mute and they're saying, "Come on, guys." Okay, I should be good lip sync reader, right? Okay, that's very difficult. That art I haven't learned. Maybe when I will join the FBI, I will learn all those things. Okay, or maybe CIA or maybe CBI, because they need this kind of expertise. Right now, I'm into different professions, so for time being, you can unmute and say. Once I am mastered that art, you can just keep on saying with mic muted. Anyway, so theta is unknown, V is unknown. The question is, it will eventually come to ground. How much time it will take? How much time it will take? It will take some time, right? So what is the best way to find the time? Which triangle will give me the answer? The velocity triangle or displacement triangle? Think about it. A velocity triangle is only meaningful if you know the angle, beginning angle and the end angle. But right now, do we know the angle? No. We only know how we have thrown in the beginning, but we have no idea how it is about to hit the surface. So now, can you switch to the displacement triangle? And can you try to draw the displacement triangle? Why I'm saying this? Because H is something which is known to you, right? You know H. So you can make use of it. The H. Can you draw the displacement triangle?
So what do we need to find out in this question?
Time. The time of flight. Like for after what time it will be touching the ground? About to touch, which means it is almost touching the ground. So delta R, if you first of all write the formula, delta R is equals to U vector into T vector plus half vector into GT square. I mean G into T square. So we have to do two vectors UT and this, and we know the direction of this vector. And we also know the direction of this vector. And eventually we want to be here. So this is my final destination. So the resultant vector must be like this. Can you see this? Delta R is this. And this delta R is made of these two vectors. One is horizontal, other is vertical. So how my triangle will look like? Can you guess? Hopefully you can guess. This is UT. And this is half GT square because it must be vertical, right? So this is difficult to realize. Eh? So after time t, you must be here. And because this is the time to reach the ground, let's call capital T, V not T. And what is the vertical length, guys? In the same time, gravity will pull down by. Let me tell you something interesting. The role of gravity is only on gravity. So whoever pulls down is gravity. And velocity is horizontal, it will only try to go horizontal. The resultant of these two will bring you down. So looking at this triangle, can you tell me something about T? Which sides are equal? Half GT square is equals to how much?
H.
H.
You're done. Half GT square is H, so we got time. And the time we got is 2H by G. Now, what is fascinating here? That answer has nothing to do with the velocity. Can you guess why? Can you guess why? Why V naught is not contributing in time? So no matter how fast you throw, how slow you throw, it will take same time. It means if I have a table and if I throw something horizontally, so it will fall like this, same time like this, same time like this. So why the time has nothing to do with the distance traveled by the projectile? Why it is coming same answer? Can you guess, guys? In fact, if you drop something, it will take same time. Any idea why the answer has nothing to do with the velocity? The answer is coming down is the role of gravity, or you can say whoever is trying to bring you down. Yeah, velocity is horizontal. So what is the component in the vertical direction?
0.
0, which means the velocity is not helping you either going up or going down. So who is bringing you down? Only gravity. So what is V not doing? In the meantime, gravity is trying to pull you down. The V naught is taking you forward. Understood? So more the V naught, you will go more forward. So your forward journey will be bigger and bigger and bigger as you make the V naught bigger and bigger. So as the V naught will grow, your forward journey will become bigger and bigger and bigger. But no matter what is the V naught, it will never help you in bringing down, coming down. So these two are two independent events. Going forward is one event and coming down is another event. And the best thing is the event is totally independent. These two events never affect each other. Understood? Are you getting the point? What I'm trying to say? And that is the reason the time of flight, the time taken to reach the ground, will remain unaffected by V naught every time. Understood? So when you throw at some angle, you increase the time. Just if you throw above the horizon, what will happen? The V naught will try to bring you upward. It will take you up, and gravity will try to bring you down. So now gravity has to work more or less. Can you guess?
More.
More. But imagine if I throw something down, I'm supporting the reaching the ground. Okay, I'm also trying to reach ground. So I will be traveling some distance. In the meantime, gravity will also support something that together will achieve the target in lesser time, right? That's the whole idea. Okay. So the time of flight is 2h by g when you throw horizontally. It was not the same as we have done earlier. Okay. Now you know the time. Okay. Similarly, if I draw the same diagram in general, let's say, let me change the color. So in the beginning, it will be not intuitive why it is happening, but as you understand the physics, how it works, you will appreciate the nature. So let's say after some time t, you are here. So you know how much you will fall down? Half gt square. And you know how much will travel forward? Can you guess? So in the time t, gravity will bring you down by v half gt square, and the v naught will take you forward by v naught t. Can you see that? Yes or no? Do you guys realize this? What I'm saying?
Yes, sir.
And see the interesting event. Someone is asking me, can you find the x and y coordinate as a function of time t? Can you find? Now it's very easy. What is the x coordinate of this point P? What is the x coordinate, guys?
Sir, 1.
X coordinate. Come on. After time t, what is the x coordinate?
V naught T.
Sir, V naught T.
Excellent. What is the y coordinate after time t? Who will tell?
H minus half GT square.
Very good. See how simple it is to solve kinematics in terms of ideas, in terms of motion. It's very simple. H minus half v square, because gravity will pull you down by half v square. So your height from the ground is h minus what you have been pulled down. That's simple. Understood? And because we have the t as a common variable, we can substitute the t from the equation 1 into the equation 2, and then what you get is the equation of path. The y and x relation is called equation of path. Do you know this name? Equation of path. Equation of path means the relationship between the coordinates is called equation of path. So right now we have a relation in terms of time t. So let me just write down. So x is equals to how much, guys? V naught t. What is y? H minus half gt square. So our coordinate is x and y. T is the called, you can name it time, you can say parameter, you can say common parameter, and so on. So this is called the parametric form of x and y variable. So the parametric form is like you try to indirectly relate the two entities, two variables. Okay. So let's say your pocket money is the parametric form of mom's contribution and dad's contribution. Okay. So you should have a good relationship with mom and dad both to have the better pocket money. You can understand this simple logic. Let's say you fight with mom, forget about the pocket money, you may lose something. And again, any instruction given to dad will also withdraw the amount. So it's very risky job. You can take risk as per your own choice. Parametric form is the dependence is direct, not it's indirect dependence. So x and y are dependent, but not directly, but indirectly. X, t, y, t. So t is the common dependence. And whenever we have a commonality, whenever we have some common dependence, we can eliminate to get the direct dependence. Okay. So what is the direct dependence? So see that mathematics, simple trick. To get the direct dependence, we can eliminate the common parameter or common variable, which is time. So can I write like this? T equals to x by v naught. And then I can substitute this value here. And the moment I do so, what I get is called direct dependence of y and x. And the direct dependence is called equation of trajectory in this case, but in general we call locus. So locus is the set of coordinates and the relation. Okay. In mathematics, it's the fundamental way to derive formulas. So when you say circle, ellipse, parabola, hyperbola, straight line, all are these called locus in general. And the whole idea of learning maths is to find the dependent relation of these variables x and y. So in high school, you might have studied the straight line y equals to mx plus c. Have you heard this name? Everyone, I know. If you say no, then I will throw out of this video. Don't say no. So y equals to mx plus c. Have you ever realized what you are trying to achieve here? This is the direct dependence of y and x. So it is a locus actually. That as x will vary, y will vary by this particular relation. So this is also the equation of trajectory, but the trajectory is a straight line. Our trajectory here is x square. What is the square represents? In mass, the square of x represents quadratic. It's called quadratic dependence. And what shape we assign to the quadratic dependence? We call it parabola. So when the power is 2, it is parabola. Power is 1, straight line. And then other shape will have some complex relationship that we'll learn in the basic of mathematics. Don't worry, I'll teach you all mathematics at once, from end to end, after vector chapter, of course. So dependence of variables in different contexts we call differently. So in chapter of projectile motion, the word trajectory is used because this is the possible path in which it will be moving, throughout its life. So everything which we throw will have some path to follow. And given the x and y coordinate, we can name the path, we can express the path as well. So what we are trying to achieve is we are trying to express the path, and that's called the trajectory. Don't worry if you don't get it now. We can do many things. And we can do even some challenging questions. So anyway, coming back to this question. Now suddenly I got interested in finding theta, but not here. I am looking for theta like this. So this is my path. Very bad. This is the height h, and I have taken the ground as, or horizontal as x-axis, and the vertical as y-axis. So at any instant t, you must be here, and your velocity vector will be tangential. Oh, let me make it small. Making some angle theta. Correct? So can you find the theta as a function of time t? Can you draw the velocity triangle? So draw velocity triangle and find tan theta. Tell me guys, what you will get? And here the velocity triangle is simple because the initial velocity is v naught horizontally, right? So you know the initial value. And just add gt, you're done, right? So can you try this out and tell me what you are getting? Yeah, I think now your audio is connected. Rugved, you can say something. Say hi.
Hi.
Yeah, now it's audible. Here the direction is simple. No? From the tip of the initial vector, draw the GT vector, and you are done.
Yes, sir, got it.
So what is tan theta?
GT upon V naught.
Excellent. The V naught itself is horizontal. So GT is like this only. So V vector will be the resultant of these two, making angle theta with horizontal. So this is a simple right angle triangle. So tan theta is opposite upon base, and we are done. So I hope someone has doubt. Okay, if you have doubt, you can ask. But this is simple. Like I think fair enough, easy. So what is the interesting find here? Given the theta, you can find time, or you can say, given the time, you know how much it will bend. Okay. So this is theta. So if I say this is alpha, can you tell me what is alpha? So when the alpha will happen, after what time? Alpha will happen exactly after what time? Alpha is happening at the moment of touching the ground. So how much time you have taken to touch the ground? We have done this, no? Time of flight. Okay, you forgot this. This is the time. After this time, you will touch the ground, yes or no? So alpha will occur after what time? Alpha will occur after time, capital T, right? Do you realize this?
Yes, sir.
I think Rugved is not getting it. Rugved, you are getting it? Or is it difficult? Just tell me, don't worry. Are you finding this too difficult or moderately difficult or damn easy?
Sir, it's moderate.
It's very difficult. Hello, 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 1, 2, 3. Are you there?
Yes, sir, I am having some problems with my mic. So
Your voice is coming like the distant cousin is talking to you.
is it clear now?
Yeah, it's perfect now. So, where is your response? I was waiting for your response. So, what is the response? You're getting
Which
it,
one? Yes, I'm understanding.
but not able to do it, right?
Yes.
Which means triangle is difficult. From the tip of the first vector, you have to learn to draw the second vector. It's a rigorous task, a very difficult task. Triangle law is difficult in terms of knowing and drawing. We know triangle law, and then we try to apply it. So that's why it's very difficult. Anyway, the answer is GT by V naught. That's simple. And if you are willing to substitute T, you may write like this, just in case, which is something interesting, 2GH upon V naught. Oh, interesting. 2GH upon V naught. Anyway, so as we learn more and more, we will come to the more all these things. My idea was to put triangle law to use, not to just learn as a maths or some sort of formula. If we are learning something, can we really use it in physics? And if not, then I think there is no purpose of learning. And if yes, then yes, we are doing something productive with our learning. So don't worry, all these topics that I am teaching right now will come again in their respective chapter, that's kinematics. And by that time, I believe that you will have some maturity to understand faster and better. Okay. So because you're looking at right now, definitely you will get some time to digest or realize, and then you will find, okay, it's not difficult. Okay. Okay, let's move to the next concept, the dot product. Yeah.
So I had a doubt.
Yes.
So in the previous slide, if tan theta and tan alpha are having the same value, then shouldn't theta be equal to alpha?
How it is same value? The t
So
has changed,
GT by V naught.
but t is changing. Na? T is variable,
So
right? T is variable. So as the time will pass, the answer will change. So it's like in a general answer way of writing. But t is when you substitute t value, definitely you will substitute different value as per different instant of time. Okay. So that's why the answer is not same. Okay, so we talked a lot about dot product, its axiom, and then I said, okay, the two vector coming together creates a scalar effect. Okay, so how to explain this scalar effect? So I gave you example of charge. A plus charge is meeting the negative charge; they become neutral, no charge. Okay, so when two vectors come closer, I mean come together and produce some effect, which is effect that we measure in scalar terms, then the way to define such event is using dot product. Okay, that's the whole purpose of using dot product. What is happening in physics? We come across a situation, let's say force and displacement. Okay, so let's say you kick your friend, I mean in a jolly mood, okay, not in a very bad way. So let's say you both are playing in the ground and then you kick from behind. After you kick, what you see? Your friend is running faster or slower? Okay, I mean, don't worry about the consequence. Just mentally kick. Don't get scared that I mean he will okay give you some punches back to you and he will be like black and blue after some time. That's a different story. Right now, what we are trying to understand that if you kick your friend, what do you expect? He will be running faster or slower? Imagine he is running away from you, of course.
so faster.
Faster. I mean, do you realize that your friend deserves some kick? Okay, I mean because he's running faster, which is like you may help him winning the race, something. Okay, so you are running and you feel really appreciate that you cannot win the race. You just kick your friend. You will cross the boundary line and then later on you can have party. Okay. The thing is, the faster in physics is called high kinetic energy, half mv square. You know, have you heard this name? Kinetic energy. Anybody who has heard this name?
Yes, sir.
So your friend was having some energy, right? So your friend was having some energy. He was running with some energy. After kicking, what do you think? Your friend is having more energy, right? Isn't it? After you have kicked your friend is having more energy than before. Yes or no? So now the question is how this energy got transferred to your friend. That's very interesting. The kick was not simple. It was pure physics kick. And this kick is so important in physics. We have a separate chapter for entire kick called work energy power. Okay. So we have dedicated the kick part. Now to translate this action into physics, what we say, you kicked means you applied force to your friend. That's the first thing. And force is a vector. Okay. And when you kick it, you don't realize that you push your friend for some distance before the contact is lost. So you can say your shoe or your foot was in touch with your friend's back for some time before you. So you push your friend for some time and then you release the contact. So there was something called displacement also. So the kick was the force and you pushed for some distance. So there was a displacement. So force is a vector, displacement is a vector, but the end result was what? Your friend had more energy. Now energy is a scalar. Now what I'm trying to explain, I'm trying to say that okay, the event was interesting. The two vector came together. Which two vector? Force and displacement. And what was the end effect? So end effect was your friend was having more energy. Oh my God. Now, of course, your friend will move faster than before. So your friend will have more momentum also. But I am talking about the scalar effect. I'm talking about the scalar effect. So what we are trying to understand through the logic is, in physics, there are many instances where the two vector quantities produces some scalar effect. And then there was a need to create some logic, some mathematical literature which can take care of such event. And that was the reality, that was the reason that gave to the birth of dot product or scalar product. So the scalar product is a way by which we can combine two vectors, but the end goal will be the scalar effect. Do you realize this, what I'm saying? It's very deep actually. I mean, you might be just thinking, okay, sir has kicked someone, but the kicking process is so deep that if you understand, you will never be the same person again if you understand what is happening here. At the same time, the kick will have some vector effect also. I'm not talking about that effect. So right now, my intention or my interest is to only reveal the scalar effect which is being produced by the two vectors. Okay. So we must define some operation which can lead to the scalar result, isn't it? And that operation we call dot product. I hope you are getting what we are, why we are learning this dot product. So the dot product is learned so that we can deal with such event in physics. In mathematics, is just an axiom. In mathematics, it is just a definition. There are many use of dot product. We can solve some question of maxima, minima using the dot product. We can prove mathematical theorems using the dot product. We can find the resultant of two vectors using the dot product. And we can do a hell lot of things with the dot product. So let's do something. Okay. So what we can do now? So I got some idea. Okay. So we have two objects, or let's take two balls. But one ball is thrown horizontally right and other is thrown horizontally left. Now, no matter what velocity you impart in the very beginning, that's called V1, V2 is the initial velocity of the ball. The gravity will pull them down by same value. So half GT square is going to be same for both, yes or no? Because V1, V2 cannot contribute in the vertical direction. V1, V2 cannot contribute in the vertical motion. So gravity is the only thing which is responsible, yes or no? Probably yes. Okay. So the path traversed by the first particle will be horizontal like this. I am throwing from parachute, don't worry. So I'm just throwing two apples in the two direction. And the other is going this way. Let's say I'm throwing it faster, so it will go like this. So what I'm trying to ask, or what I'm trying to achieve is this question. My question is, after some time, the velocity V2 will be something like this, right? Let's call this as V2 dash because V2 is the initial value. It's a vector, okay? And after some time, the V1 vector is something like this, let's say. Okay, they must be at the same height, so I will just keep it height same. Yeah. And let's call this as V1 dash. Okay. So what we do next is we try to extend this line backward, and we extend this line backward. And we realize that after some time, this angle was 90. which means the V1 dash and V2 dash are mutually perpendicular. Okay. So they are on the same horizontal line for sure, because that's a property of gravity. And this event will happen at exactly some time t. So if I call this as t equals to 0, and if the moment their velocity directions are mutually perpendicular, we'll have some time t. So before this event will occur, some time must have been elapsed, yes or no? So what is the question? Question is, find the time after which time their velocity vectors are mutually perpendicular. So here we have a simple question. You can call simple, you can call tough. Again, this question is from kinematics, but we can make the use of dot product to get this answer in one line. And why I'm saying dot product? Because when two vectors are mutually perpendicular, then that dot must vanish. So can I write, because V1 dash is perpendicular to V2 dash, can I write V1 dash dot V2 dash must be 0? Yes or no? Tell me guys.
Yes, sir.
Okay. Rugved, you are getting this point? What we are trying to achieve here?
Oh, sir.
So now the question is, can you express V1 dash and V2 dash in terms of velocity, I mean the kinematical formula? V equals to U plus AT, you know? So you know the formula, V vector equals to U vector plus GT vector for any projectile motion. So can I write V1 dash vector equals to V1 vector plus G vector into T? And similarly, can we write a V2 dash vector is V2 vector plus G vector into T? Can I? See, I'm writing in vector form. You can convert it into scalar later on. So now, because we can write like this, you can substitute in the dot and multiply and tell me the answer. Tell me the answer. What is the answer? How much time is coming? Okay, after solving. Guys, are you able to draw the triangle first? Sorry, in here you just need to substitute the value.
So can we show this once?
Yes, of course. So anyone getting the answer? So V1 vector plus GT vector dot V2 vector plus GT vector. And this must be equal to 0. Not play with the dot. A V1 dot V2. V1 dot V plus V1 dot GT plus V2 dot GT, or I can just write GT. And the last is GT dot GT, which is like G dot G into T square, because I can take T separate. Now, if you look at the first two vector V1, V2, okay. So V1 dot V2 will be how much? What is
So
the
0.
no
0.
V1 dot V2? Why it is 0? What is the definition of A dot B? A B cos theta. What is theta here?
90.
180. What is the angle between V1 and V2? Come on, guys.
Sir, but you have written that V1 into V2 is 0.
Oh yes, sir, 180.
V1, V2 is thrown horizontally, no? In the opposite direction.
Prashant sir, that is V1 dash, V2 dash.
Yeah, V1
Oh.
dash is different. So the V1 dash is different. That's so we have converted into formula. And V1 and G are mutually perpendicular. You see, V1 is the initial value and G is like this. The angle is 90. So this is 0. Do you realize this is 0? This is 0. And G dot G becomes G square T square. So we know the cos 180 is -1. So this will become minus V1 V2 plus G square T square equals to 0. So T becomes under root V1 V2 upon G. This is from IE Erodov. Have you heard this name? Erodov?
Sir, is it a book?
So you all have to buy this book. Problems in Physics by IE Erodov. Let me share the pic. You can go to Amazon. At least meanwhile, if you don't have the book, you can download free of cost. So the book name is Problems in General Physics.
Sir, is it the Arihant wala?
Yeah, that's fine because nowadays Arihanti is only selling. It's okay. So this book you all have to buy. It's a very expensive book in terms of solving and very cheap in terms of buying. Okay. So the first book I sold in my life was I Rodok because I bought it for 20 rupees, and that much money only I had that time. So I sold this entire book. Thought of it's a cheap means easy. Later on found okay, SRM is easier. So the dot product is a way to attempt many questions. I'll show you some interesting question of dot product. Okay, you can see if you want to see. Then this question is clear to everyone.
Yes, sir.
Okay, can you try this question using triangle law? You can. So try drawing two triangles side by side, like near the V1, V2, and then probably you can get the answer. So you can try for one. I will show you the other method.
Sir, with triangle, how will the triangle be?
So triangle is going to be right angle, na? Because V1 and GT are mutually perpendicular, right?
Yes, sir.
Yeah. So anyway, you try. I'll just show you. Okay. So let me show you. Are you guys there?
Yes, sir.
Yes, sir.
Okay. Switch on the video so that I can see. That gives me some energy to teach. So as a teacher, I need to see some faces. You can wear mask. That's okay. But not a Joker mask because that's very dangerous. I may get scared also. Okay, so nevertheless, let me draw this. So once you draw something like this, see the vertical height must be same, correct? So in time t, it will also have gt here. It will also have gt here. Do you realize this? And this is the v2. This is the v1 vector, correct? So the final velocity vector is like this. For the left part, this is the v2 dash, if you remember, and this was the v1 dash. Okay. Now it's a really bad diagram because it doesn't give the idea it's 90. But you can see this angle. I have told you that this is 90. Correct? So if I say this angle is theta, this must be 90 minus theta as per the assumption, right? Correct? And
Yes.
now you can see the tan theta, what I can add in the left triangle. In the left triangle, tan theta will be gt by v2. In the right, I can draw the cot theta. And the cot theta is how much? Cot theta is, you can see.
Reciprocal of tan theta.
That's I know. Thanks for informing me. I mean, I was totally unaware.
Gt by
V2
V1.
by G.
V2 by G2.
So you were talking about the right triangle. No?
Yeah. So in the
Gt by V1.
yeah, so it will be like cot theta is like gt by v1, right? On the right triangle, I am writing cot here. and I'm writing 10 here because of the obvious reason. Now, what is the next step? Multiply, and it will have magic. Tan into cot. Vanish. G square T square by V1 V2. I am doing the multiplication of 1 by 2. And see, I'm done. It turns out to be same answer, right? So the T turns out to be root V1 V2 upon G. Am I right?
Yes.
Hmm. In fact, I have the third method also, but that's too much. So what is third method? So third method is something that you will appreciate. No one appreciates the first two methods. I don't know why. Because no one likes vector. That may be the reason. Yeah. Or maybe I'm teaching so bad that no one is liking vector. That's also possible. So the third method is really interesting. You can enjoy it. So you can say V2 dash is how much? U plus AT, right? That's the formula. But I can write as just a moment. Okay, sorry. So V1 dash is what? What is the formula? V1 plus G vector into T, right? But this is something that you will not appreciate. So what you will appreciate, I know. I know what you will appreciate. I'll make this as x-axis. This is y. So can I write V1 equals to V1 I cap? No, that's easy. And I can write G equals to G minus J cap. That's easy. And similarly, oh, my bad. What I'm writing. This is V1 dash. My bad, my bad. Similarly, what about V2 dash? V2 minus I cap, you can see. And plus G minus JT, like simple. And what I said that V1 dash and V2 dash are mutually perpendicular, so it must be 0. So V1 I cap minus GT J cap dot minus V2 I cap minus GT J cap must be 0. Now we know the formula. I will go with I and J with J. So V1, V2, I1 dot I1, I cap dot I cap is 1. So we are done. And next time is G square T square J dot J again 1. So we are done. So we got T equals to slightly easier to comprehend why we are getting the answer.
So can you please explain the tan theta cos theta method again?
Okay, okay, okay. So, okay, you use the left triangle, and this is the right triangle. Okay. So what is the left triangle? tan theta equals to GT by V2. We are writing only value. On the right triangle, what is cot theta? So cot theta will be, theta is here. Cot theta is what? Base upon opposite, GT upon V1. Correct? And now once you multiply these two values, 1 and 2, tan into cot is 1. So 1 equals to G square T square by V1 V2. So T equals to under root V1 V2 by G. Guys, is this clear? Is this clear? Okay. So you can do this question also. I mean, I can give you a lot of questions you can solve. And all are from kinematics. But we are doing with just simple application of vectors. I hope one fine day you guys will appreciate vector. I don't know why people don't like vectors. They want to learn kinematics, but not vectors. Okay. But I will insist that please keep on appreciating. Okay, try to appreciate vector. If you don't like it, don't leave it. Try to get acquainted. So let's say I'm throwing something with velocity v naught at an angle theta from horizontal. Question is, after what time the velocity vector will become mutually perpendicular compared to the initial velocity vector. So I want to know that at some time t, this v vector, which I don't know how much is that, I have no idea at all. But I know only one thing, that this angle is 90. So after what time this will occur or this will happen? There are many ways to solve. You can use dot product, you can use velocity triangle, you can use kinematical relation, kinematics, and everything else which you know. So you first try to solve using the question is, find the time after which the velocity vector becomes perpendicular to initial velocity So there are 1,000 ways to solve, but you can just solve by the 1-2 ways. That's enough.
Sir, I got it.
Very good. How much?
So T is equal to V naught sine theta by G.
Very close. It is other way around, I think. G not by G sin theta. Can you just recheck? You can draw the triangle first, right? In which the V naught, the tip of the V naught and the GT will start from there, and the beginning of the V naught and end of GT will make a triangle in which V and V naught should look perpendicular. That's the idea. Do you realize this? And see, the GT is big enough. This is the V naught. Look at this. It's so easy. You can do in one line. Just try to realize this. This is V vector, the final vector. So first, second, and V. And this is 90 given, right? And this is also known to you as theta. Correct? So this will be how much? 90 minus theta. And this is how much? Theta. Correct? So if you look at the triangle ABC or maybe OAB, in the bigger triangle, so what we can do? Sine theta is how much, guys? Tell me. In a big triangle, what is sine theta? This.
Sir, can't we use a smaller triangle? A
No,
smaller.
you cannot use because this is not GT. This is half fraction of GT. The GT is the full length. Do you realize this? This is your GT, no? And if you use the half triangle or the upper triangle, then do you know this length? No, you don't know. So in this triangle, look at this triangle. This triangle is your right angle triangle. This is the right angled triangle. Can you see that? No. So try to see this triangle. In this triangle, what is sin theta?
V naught by GT.
V naught by GT.
Exactly. So what is the T value? V naught by G sin theta. Is it difficult? Yeah, it is. I won't say it's easy. So at least everyone will draw this triangle on their own and will try to get the answer. Everyone, please draw the triangle. Always repeat the same question. If you don't get it, repeat it. With repetition, you will get the right answer. So don't worry about it. Okay. Then guys, are you able to recreate the same triangle with your own
Yes, sir.
thought? So who is not able to, like, not finding it convenient, like, sir, how you're drawing the triangle? I never do the triangle in my life. So how difficult is to draw three sides on a blank sheet of paper? Okay, I'll start with Rugved because he is quite silent. Rugved, how difficult is to draw the three sides of a triangle?
Not difficult.
Not difficult, but I haven't got any response from you, so it is difficult slightly. Okay, Shreya, how difficult is that? Okay, she is not there. Maybe she has slept. Three sides are so tiring. Okay, Siddhant.
Sir, damn easy.
Okay. Prashansa, okay, okay, she's lost. She's gone somewhere. Okay, you are there. How difficult is Prashansa to draw the three sides on a blank sheet of paper?
So sometimes it is difficult, sometimes it is very easy.
Right. So what you realize that everything which we know, we cannot put into the category of easy or difficult. It is only the practice which makes something easier. In the very beginning, I said that the most challenging part of learning physics is addition, subtraction, multiplication, and division. Okay. And now the difficulty is somewhere else. We are seeing that drawing the three sides is also a challenging task given the constraint that you are supposed to draw only in certain way. So the moment someone is putting the constraint, the same easier thing becomes difficult. So nothing is difficult in physics or nothing is easy at the same time. Once you practice, once you realize, you will find it's easy, else difficult. So don't put anything into the category of easy or difficult. But let's say if I'm trying to solve this using the dot product, how I'm going to do? The initial velocity vector, how to write a vector in I and j cap notation, if you remember? So let's put it into, how to resolve a vector. We have done the resolution of vector. How to resolve a vector, right? So how to resolve V naught in terms of I and j?
Sir, V naught cos theta I cap.
Excellent. Another?
V naught sin theta j cap.
So writing I and j cap is pretty interesting because that makes things easier for us. Okay. And how to write the V vector? By using the kinematical relation, V vector equals to initial vector plus G vector into T.
GT.
That's it. So you can write a V naught vector. Okay, I can do in two ways. I'll show you two ways. This is easier one. I mean, I need not to do this. And what is the angle between V vector, V naught vector and the G vector? Can you guess? Let me draw the tail to tail. What is the angle between G vector and V naught vector?
90
90
plus
plus
theta.
theta.
Very good. So you have done everything. Now see the magic. V dot V naught must be 0. Yes or no? Tell me. The initial and the final are mutually perpendicular, so the dot must be 0. Yes or no? Tell me, guys. If you
Yes.
don't say, I will not do.
Yes, sir.
So can I write V equals to V naught plus GT dot V naught equals to 0? And now you know the magic. V naught dot V naught becomes V naught dot V naught. V naught square. Okay. Plus G dot V naught into T equals to 0. What is the A dot B formula? AB cos 90 plus theta. You know the formula, A dot B formula? AB cos theta. Now it is easier said than done. That A dot B is AB cos theta. Sometimes we know, but still see, How difficult is to apply? You need to find the angle in a situation like this. But now the next difficulty is, what is cos 90 plus theta? So 90 plus theta, which means second quadrant, which is minus sine theta. That you will learn in trigonometry. Don't worry. If you don't know, totally okay. So can I write this as V naught whole square minus 2, sorry, minus, my bad, G V naught sine theta into T equals to 0. Can I write like this?
Yes, sir.
And I'm done. So T is how much? V naught square by G V naught sine theta. Oh, I can cancel. V naught by G sine. You may not appreciate this way of writing. You can write in component form. V naught cos theta I cap plus V naught sine theta J cap plus G minus J cap into T. And again, you can take the dot with I, J with J by rearranging the terms and doing all the permutation and combination. Yes or no? So can you try this way of writing and then taking the dot and tell me whether you are getting the same answer or not? Please try, everyone. That's my request. Please try. See how much comfortable you have become so far. It will never happen in one day. You won't be comfortable with vectors in one day. But if you decide that one day you have to become comfortable, keep on trying, you will be in a position to feel vector one fine day. And then you will appreciate vector. Today I will not extend the lecture. We'll finish by 8:30. So many will have their lecture afterwards. You can take a break, have some snacks or dinner, and then go with energy with the next lecture. See, I could have finished the chapter entirely, totally. Like we could finish the entire vector in 4 to 5 lectures. But there is no point in learning vector for the sake of completing. The whole idea of learning here is, can you apply it? The application is my interest. So until you will not prove that you have learned the application, I will not leave. So if you want to move faster, learn quicker, you will save time. So practice is the key to learn physics. Finishing the chapter will not help anything. I mean, let's say I finish kinematics. What will do with you? I am finishing kinematics, and what you will do? Is it some sort of certificate that, okay, this is the certificate, I am giving you a certificate that, okay, this chapter has been finished, and therefore you deem knowledgeable in that topic. Okay, such kind of certificate I cannot issue, right? You have to prove through the practice that you have learned something. So that's why I'm saying, do the pen and paper work, do the dirty work of writing, and learn through writing, not through listening. Only one guy in this universe had this privilege of learning without writing. Now that guy is no more with us. You know the name? Ramanujan. Now he is like genius, so of course he can do without writing, but we cannot do without writing. So he left many proof in his book, and he mentioned that I'm leaving the proof for the lack of margin. Because in the book, the margin was not sufficient to mention the proof. But he wrote the end result. Now he was genius. To decode the end result, it took 100 years for mathematician. So if you think you are Ramanujan, you can avoid writing. But that is very rare. I mean, if you're Ramanujan, then I can start paying fee to you and you can teach me something. So anyone who believes they are Ramanujan or the distant relative of Ramanujan, I am not, for sure. So please use pen and paper, write as much as possible, make all paper dirty. That's called the dirty work. Writing is called dirty work in learning process. And any student who is not writing every day 10-20 pages, you are totally wasting your day if you're not writing. Even when you read chemistry, I will suggest that write something, write the formula, write the diagram, okay, the reaction or the structure of the molecule. The writing is very powerful method to learn. It creates a hand-eye coordination, and then brain is at ease with remembering the things. That's very, I mean, it's a physiological event actually. So for you it may be just one event, but physiologically it is proven that when we write we remember a lot of things.
So I had a doubt.
Yes.
So why did you take V naught as V naught cos 90 plus theta?
Because what is the A dot B formula? Let's see, we are getting G dot V naught. So what is the definition? A dot B is A mod of A mod of B cos of angle between them. So the angle between G vector and the V naught vector is how much? 90 plus theta. And that is why we can add cos 90 plus theta, which itself is minus sin theta. So I simply substituted the value of this as minus sin theta after this step, and then I got the answer. Tell me guys, how many pages you wrote today in my lecture? I'll start with Shreya. Shreya, how many pages you wrote today? Count the pages.
7.
7.
Yeah.
And Siddhant, how many you wrote?
Sir, 5.
Prashansha, how many?
So 5.
Rugved, how many?
8.
8. Oh, so you have wasted pages, huh? Empty space in pages. Okay, nevertheless, that's okay. But the good thing is, I'm really happy. You all have written something. Yeah. But okay, I think I'm okay. No, I have written only 8 pages. So I think Rugved and I are the winner. So I will declare Rugved and myself as a winner of this contest. Rest you guys, you can write more. Or maybe. Because I took 8 pages. So you should have taken more than me. Huh? Oh. So no diagrams. I think your page will have no diagram. That's why. And have you drawn all the diagrams today, which I have drawn on here? So that's very interesting. See, 2 things that we have to practice. We have to always draw the diagram for every question, no matter how bad the question is. Even if the question is like, who is the father of Akbar? Draw a diagram, like a tree diagram. The father, some arrow, then okay, Akbar, and make sure that no matter what the question is, you must draw some diagram. Okay. So let's say you kicked your friend, so you can draw you, then arrow, kick, then friend, and make sure that you have some diagram in your, because in physics, if we do not have the habit of drawing the diagram, almost it's 20, like it will become like 10 times difficult to solve numerical. The moment you read something, you have some picture. If no picture comes, then you can draw something like this. Maybe, I mean, if you're not getting any idea, draw maybe some cloud, okay, blank, because you have no idea what to draw. So do something like this. Okay, but must make sure that you draw some picture. If your art and craft class you have missed in or skipped in school, do practice from the previous notes of class 6 or 7. Make sure that you all have habit of drawing something. I have the habit because I skipped. So I practiced later on after school. Okay. I got 0 marks in art and craft because I had a fight with my teacher. He said make handicraft. I made the paper plane. He gave me 0. I said that's handicraft. Come on, but still he gave me 0. And then after that, okay, I thought of giving him a boat, but okay, no, that was of no use. He said I don't expect boat or plane from handicraft lecture. Give something more substantial. So I said what? He said give me pen. I mean, see, this is not handicraft. It is manufactured in company, and I'm not owning the company. Come on. Anyway, the fight continued, and I got 0 only. So that's the history. I will suggest always draw diagram. Okay. Make sure that you have very good habit of drawing something. No matter you're studying English or history or civics. In physics, okay, we have to draw a lot. Okay, so if these are some small habits we must inculcate, and once you inculcate these habits, you will see that you are no more the same guy. I mean, you have gone to a different level altogether. Okay. So I will not put a lot of burden because last lecture it was very hectic. Now let's keep it cool. Next lecture I'm going to start the but I can do one more problem. I don't want to end with physics. I appreciate mathematics. So you all have heard something that triangle in a semicircle is always a right angle.
90 degree.
Yeah, 90 degrees. So if you draw, no matter how bad you're with art and craft, but geometrically, if you draw any triangle, and it doesn't matter whether you know physics or maths, if you draw, you will end up getting a right angle triangle, right? So can we prove that these two are a right angle? And again, the dot is the rescue. In dot, we know that if something is right angle, the dot must be 0. Okay. So by properly converting this entire diagram into vector, I can achieve the target. So let me show you how I'm going to achieve the mathematical proof using vector. So first of all, I will take the center as the origin. That's very logical choice. What next I'll do? I will join the center to that edge, to the vertex, my bad. And now what I'll do is I'll put the naming. So let's call this vector as A vector. And if this is the A vector, what do you expect this vector is?
minus
Excellent. Who said this?
Rugved.
Yeah, excellent. Come on. You have never shown this aspect of yours. So it's minus A. That is the only thing you need to know. And you're done actually. So the only vector which I need to assume is B. And why I'm assuming this, it's again logical. I know these vectors are having equal length because they are representing radius, right? So can I say that mod of A is same as mod of B? Is same as the radius? Is it okay?
Yes.
Tell me, yes or no. Very good. So what we are trying to achieve, we are trying to prove that BC and AC are mutually perpendicular. Let's call BC like this. AC doesn't matter how you assume. So I'm trying to prove that BC dot AC. And I don't know whether it is 90 or not, but if it is 90, it must come out to 0. So what I'll do is I'll assume the LHS. My whole effort is going to achieve the target. How to write BC vector? OC minus OB. That's how we write. See the B and C. C is the next and B is the. So we take the after number like the second, you can say alphabet. So OC minus OB is BC. Dot. How to write AC in terms of origin? AC will be OC minus OA. See C and A. So A comes first, C comes second. So second minus first from origin. But anyway, if you don't believe me, use triangle law. What is triangle law? Can you see the triangle law? In this triangle, what is the relation?
OB plus BC equals to
OB plus BC is OC. Am I right? And in this triangle, guys,
OA plus AC equals to OC.
OA plus AC equals to OC. So you can clearly see that AC turns out to be OC minus OA. And you can clearly see BC turns out to be OC minus OB. The same thing what I wrote earlier. It's easy. Without triangle law, you can also write. How to write without triangle law? Final minus initial. C minus B, C minus A, and then put O. Once again, can you see the pattern? There is a pattern you can check. C minus A, C minus B, C minus A. Can you see? The way I write the alphabet, you can take the final minus initial. Let's say if I write PQ, how to write PQ vector in origin form? OQ minus OP. That's trick. Oh, you're not getting it. Okay. So maybe let's say we have a vector called Kadi vector. OD minus O. That's simple. Or maybe the Tom and Jerry vector. Tom, this is Jerry, this is Tom vector. So how to write O
O Tom minus
Tom?
O
Oh,
Jet.
and the viscous I have forgotten. Anyway, you can add viscous for the Jerry also. The Jerry is now old, so we have to add an O Jerry with some viscous, right? So don't forget to add viscous, else Jerry will be feeling bad about me that I have got only half of n diagram. So this is the simple pattern. You can understand the pattern, you can write it. Now, can I prove it? Yes, I can prove it. So let's write the dot. OC is what? OC square. OC. Can I add OC square? See, magic R square. Because both are radius, no? So lengthwise there are OC is OC square. When OC mod is how much? R radius. Can I write like this? Or anyway. What is OC? OC was B vector. OB is minus A vector. Dot OC is B vector and OA is A vector, correct? So B plus A vector dot B minus A vector. So B dot B square. B dot A minus B dot A. A dot B, A dot B. A dot A minus A square. And this will cancel out to each other. So what will left with B square minus A square? But length of B is R, length of A is R. Oh my God. BC dot AC turns out to be 0. The dot says they must be mutually perpendicular, hence proved. See the power of vector. I can prove any theorem. So with the help of theorem, we can prove multiple, with the help of vector, we can prove multiple theorems in mathematics. And of course, you will have to do it anyway in maths. Okay. So I'm trying to give you the glimpse of mathematics which you need to learn. Eventually, we are going to solve questions for maths also. So mostly I'll give you assignment soon, mostly from mathematics book one. So you can actually finish the vector from physics also and vector from maths also, almost 80%. Why 80%? Because 20% is something which I will not teach because that's not part of the physics syllabus. It is mostly theorem, proof of theorems, and some advanced concepts are there which you need to practice in maths only. Okay. Okay. All right. So with this, I'll end today's lecture. There are many things that I will prove in the next lecture, and we'll start the geometrical meaning of dot product.
So
Yes.
in the previous slide, you wrote B vector plus A vector dot B vector minus A vector. Can we directly use the b square minus a square minus b square formula and write it as b square minus a.
Actually, you can write directly, but the thing is, it will be coincidence that a dot b is same as b dot a. Imagine if I write b plus a cross b minus a, then we cannot write, because the cross product is very unique in terms of definition. So in vector, we have to see what will happen. In vector, generally what happens, your intuition about the algebra sometimes matches with the vector, and you end up thinking that they are same, but they're not same actually. I mean, it is like, how to say this? I mean, let me give you some nice example. You can remember this. Okay. Something is nice. I mean, the vector and scalar sometimes matches. In one dimension, what happens? The properties of vector and the way you think speed and velocity. So velocity is direction and magnitude, and speed is what? Only magnitude. Direction is not, something immaterial. So in the dot product, when you write a dot b and b dot a, both are same actually, because it is commutative, and because it's commutative, it will behave as if you're doing the scalar multiplication. Okay, it is quite different in terms of cross product, because a cross b is not same as b cross a, and in fact they will get added together. So a cross b minus b cross a will become, okay, anyway, we'll come to that. So anyway, what is a cross b? And a cross b is actually minus b cross a. So someone writing a cross b minus b cross a is actually twice of a cross b. See, it is not cancelled. This is wrong. You can't cancel because of some property. So yeah, of course, in dot product you can say directly, but I will not suggest. Why? Because sometimes when you study in the higher, studies, the topic is called linear algebra. The dot will behave quite differently. So there is a topic in maths called linear, and this comprises of the entire matrices, vectors, and so on. Okay. So vector itself is called vector algebra. We don't study vector. What we study? Vector. And there are some rules. What I said, there are some rules in vector algebra which we have decoded in a different literature. But while creating the rules, we borrowed some symbol from the old algebra, and that's why we get confused. So for example, I said a plus b. Are we really adding something? No. It's a literature which means a and b, right? When I add a dot b, are we really multiplying something? No, we are denoting. It's like the ritual. You go to some marriage ceremony and you see the bride and grooms are in certain dress code. ऐसा नहीं कि, I mean, they are in the Bermuda and marrying each other. I mean, of course, they have some decorum to maintain. So it's like convention, some sort of, you can say, mathematical tradition. And every notation refers to some sort of definition. Okay. So while carrying the symbol from the old book of algebra to this new book of vector algebra, we have changed the meaning, kept the symbol. Okay. So when I write a minus b, are we really subtracting something? No, we don't subtract. What we do? We add a and the reverse of b, the b vector. Are we really subtracting? No, we are adding a and the reversed vector of b vector. So you reverse the b vector, you get a new vector, and then you find the resultant with the a vector. So the meaning and the representation should be decoded as per definition. We should not use in any way the old algebra. It's good to write an realize. So luckily, what happened? The b dot a, b plus a dot b minus a, it turned out to be how much?
B
B is
square
minus
minus A square.
this is just sheer luck. It is like the old algebra, right? But we are operating on vectors, correct? So we are operating on vectors. This is not the normal thing. So basically, how big is this number? This is actually, let me show you. This is actually bx square, by square, bz square minus ax square, ay square. So actually, what you can see, there are three separate numbers creating this effect. Do you realize this? So a plus b into a minus b is not a square minus b square. It's a triplet of that. Because inside the b, it's a bracket. B is a bracket. Inside the b bracket, we have three components. Inside the a, we have three components, which you don't see. Now, in regular mathematics, b and a represents single term, right? But in vector, b and a represents combination of terms. Do you realize this? So symbolically, it is one, but is it actually one? No, it could be one, it could be two, it could be three. Now, because we add numbers, which will result into a number. So you can say it's eventually a number. Yeah, that's correct. Eventually, it's a one number, but this one number was generated using three separate components. So b square minus a square is huge term here. It is not simple, as you understand the general algebra. The general algebra is about single number, one, one. Okay, anyway, don't worry. All right, guys. So you can take rest now. Enough for today. And we'll see in the next lecture on Friday with some new concept to practice. And what you can start doing is you can start the sheet which I have shared, the part one, part two. I have shared some question bank, I think. Have you got the question from me? Let me check. I think I have shared. I have shared. Yes, in the beginning only I have shared. Yes. Just a moment. Mathematical tools that I have sheet is there. In the very beginning, if I have not shared, I shared again. Maybe many have done it. So just a minute. Just a minute. Yeah, you can see now. It is there. Can you see mathematical tools? You can go inside. This will be quite easy actually. So you have to come to page number 43. The PDF page 43. So first it starts with some mathematics, integration, calculus. Now it comes to vector. Okay, it's page 47, where the vector starts. You see page 47, part 3 vector. So
Yes,
you can
sir.
see section A, section B, section C. All three sections you have to finish. A, B, all are very easy. I mean, you can do in maybe some questions are from cross. You can leave it because I haven't taught you cross. So don't worry. Then exercise 2, go to the again part 3 and finish all questions. Same. This is part 1. Sorry, part 3. exercise 1, then exercise 2, again part 3. All questions you have to solve. That's it. So I think that is enough for today. These are very easy questions. You can mostly finish in 1 hour. That's a entire effort you have to put. And anything beyond, I will share again because I think I have missed sharing with you guys. Just a minute, let me see. I have shared already. Come on. You can see the level 1, vector sheet level 1 as a heading. 12 pages. No. Once again. Now you can see. You can see now level 1, something I've shared. So from here again, you can solve almost all questions as much as you can. So we have a lot of questions here for practice. Answer key is also given there. So try to finish as much as possible. Okay, that's it. Okay, bye guys, take care, and do submit your solution before the next lecture, which is on Friday. Enough time. Bye guys, take care.
Thank